Morning, everyone. Myself, Monica Nansikia, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W25601 Basic Electrical and Electronics Engineering. In the Regulation 2025, uh, today, in this session, we are going to study an important electrical machine called a generator. Specifically, the DC generator. Generators are the devices that converts mechanical energy into electrical energy. So they play a very important role in power generation system. For example, in power plants, mechanical energy produced by the turbine is converted into electrical energy using generator. So in power plants also we are using generator. So we will discuss the basic principle of operation, construction, parts, working, and the application of the DC generator. So what is mean by generator? So generator is an electrical machine that converts mechanical energy into electrical energy. So the mechanical energy can be obtained from the turbines, that is engines, water flow, or wind. These are the mechanical energy obtained from these sources, and the generators are mainly classified into two types, that is DC generator and AC generator. So in DC generator, it converts mechanical energy into direct current electrical energy, and the AC generator is said to be the alternator also. It converts mechanical energy into alternating current electrical energy. So both AC and DC generators operate based on the Faraday's law of electromagnetic induction. When a conductor moves in the magnetic field, the electric current is induced in the conductor. So the mechanical energy is converted into electrical energy is said to be the generator. Next one is the principle of operation. So start with the historical background. The operating principle of generators was discovered by the English scientist Michael Faraday. So that the name of the principle is said to be the Faraday's law of electromagnetic induction. That is, whenever a conductor cuts the magnetic field. So this is the magnetic field. The conductor which is cut the magnetic field, magnetic flux, the EMF is induced in the conductor. This means if we rotate a coil inside the magnetic field, so the electricity will be generated. So what is the condition? If the circuit is closed, the EMF, the induced EMF will produce the current. So the principle is similar to how electricity is generated in the hydroelectric power plant also. So next one is the construction of DC generator. So in the structure of the DC generator, we are having the yoke, pole, field windings, armature winding, commutator, brushes, rotors, bearings. These are the main parts of these. All these components work together to convert the mechanical energy into electrical energy. So we have studied the each part one by one. First one is the yoke. The yoke is the outer frame of the DC generator. So it protects the internal part from the dust, moisture. So it provides the mechanical support to the poles. It acts as the part for the magnetic flux. The yokes are usually made from cast iron, cast steel, silicon steel, or rolled steel. So the iron materials are used. So they help to conduct magnetic flux efficiently. Next one is the pole. These poles are mounted on the inner side of the yoke. So the main function of the pole is to produce and distribute the magnetic flux. When the field winding is energized, this is the field winding. We have wound the field winding on the pole. So when the field winding is energized, the pole become electromagnets. So the poles are usually made up of cast iron or cast steel. Next one is the field winding. Now here the pole, here see, the field winding is wound on the poles. So the field winding is also called the exciting winding. When the electric current flows through the field winding, it produces a magnetic field around the poles. So the copper is generally used for the field winding, has the high electrical conductivity. So this magnetic field is essential for generating the electricity in the armature. So next one is the armature core. This armature core is the rotating part of the generator. This armature contains the slots. Here we are having that is the teeth-like structure. No, that is the armature slots that run the parallel to the shaft. These slots hold the armature conductors. These slots hold the armature conductors. This armature core provides the low resistant part for the magnetic flux. This is also made up of the cast iron or laminated iron. So this armature core is wound as a lamination. This lamination helps to reduce the eddy current loss. Next one is the commutator. So the commutator is one of the most important part of the DC generator. The commutator converts the alternating EMF produced in the armature into direct current. Because this is the DC generator, no, we are getting a supply from the AC. So we are converting AC to DC with the help of the commutator. So the commutator collects the current from the armature winding and transfer it to the external circuit through the carbon brushes. So without the commutator, the generator would produce AC instead of DC. Next one is the rotor. The rotor is the rotating part of the DC generator. So the rotor rotates inside the magnetic field. The interaction between the magnetic field and the current in the conductor produces a torque. So this causes a rotation. This rotation is necessary for cutting the magnetic flux and generating the electricity. Next one is the working of the DC generator. In this working of the DC generator, this mechanical energy rotates the armature coil. This coil rotates inside the magnetic field. As the coil cuts the magnetic flux, the EMF is induced in the conductor. So the induced EMF is initially the alternating and then the commutator which is used to convert the AC into DC. So what is the output? The generated DC current can be supplied to the electrical loads or stored in the batteries. This DC generator converts the mechanical energy into direct current electrical energy. So these are the working and the application is so the applications. What are the applications for the DC generator? For the shunt generator, this is used for the lighting system, battery charging. For the series generator, is commonly used for the arc lamp and the constant current sources. So in additional uses, the DC generator are also used in boosters in DC power systems. So the DC generator plays a vital role in all the yeah, power plants. So the DC generator, today we studied the DC generator construction, parts, working principle and application. So DC generators are important machine used to convert the mechanical energy into electrical energy. So these are the references. Thank you.